Auzubillahi minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello students. My name is Oladimeji T.A., the Ss2 Physics teacher of CTY Model College, Ibadan, Oyo State, Nigeria. You are welcome to the second period of week 7 of our e-learning physics class for third term for 2019-2020 academic session. In the previous class we started a topic, refraction of light waves, and we were able to look at refraction of light through rectangular glass block. And in this second period for this week, we want to look at refraction of light through a triangular glass prism. Refraction of light through a triangular glass prism. We defined refraction in the last class we had as the change in the direction of light as the light travels from one medium to another due to the change in speed. So refraction also takes place through triangular glass prism. So to study the refraction of light through triangular glass prism, we will need the following apparatus: a triangular glass prism, 4 optical pins, drawing papers, a protractor, and a ruler. The procedure is as follows. 1. Place the triangular glass prism on the drawing paper and trace its outline ABC. 2. Remove the prism and draw a normal to pass through the point Y on line AB. 3. Draw a line XY shows that angle of incidence I is equal to 30 degrees. 4. Place the 2 pins on line XY. The pins should be reasonably separated and replace the prism on its outline ABC. 5. Looking through side AC, place the third pin at a point out such that it is in a straight line with the images of the first 2 pins. Place the last pin at another point here so that the 4 pins are in a straight line. 6. Remove the prism and draw a line RS to meet AC and at Y and extend it to a point W as shown in the diagram below. This is what they are saying in this diagram. You place your triangular glass prism, you trace its outline ABC. After that, you remove it, then you draw a normal to side AB at point Y. Then draw a line XY to represent the incident ray and let this line make an angle 30 degrees with the normal to represent the angle of incidence. Then after you've done that, replace your triangular glass prism ABC. Then go to the other side AC. Look through the side to view the image of the pin you placed on XY. The 2 pins must be reasonably separated. Then you look at the other side AC. You look through their images and place the 3rd and 4th pins in such a way that they will be in a straight line with the images you are seeing in the triangular prism. After you've done that, remove the prism and join the line RS. Then draw the normal to the surface and complete the diagrams as shown. Then, from the diagram, I is the angle of incidence, R is the angle of refraction, E is the emergent angle, while D is the angle of deviation. The experiment can be repeated for 4 other values of I: 35 degrees, 40 degrees, 45 degrees, and 50 degrees to verify Snell's law. Remember, Snell's law is the second law of refraction. That is, the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant for two given media. So if we tabulate the result obtained for high half, sine high, and sine half, and plot a graph of sine high on the vertical axis against sine half on the horizontal axis, the slope of the graph will give the refractive index of the glass. This value should be approximately equal to 1.5, which is assumed to be the refractive index of the glass. Also, if we plot a graph of angle of deviations against angle of incidence, we should obtain a minimum angle of deviation, which is denoted with letter dm. This is the smallest angle of deviation produced by the prism. At minimum deviation, the light passes symmetrically through the prism, that is undeviated, as shown in the figure B below. Under this condition, that is at minimum deviation, the angle of refraction at y and r will be the same. So from geometry, the refracting angle A is equal to 2r, and the m will be given by 2i minus a, where I is the angle of incidence and a is the refracting angle. In terms of angle of minimum deviation, dm, refractive index n is given as n is equal to sine half dm plus a over sine half a, where dm is the angle of minimum deviation, a is the refracting angle, and n is the refractive index. So the following example will show how we can apply this formula. Example 5. An equilateral glass prism of refractive index 1.5 produces a minimum deviation when a ray of light strikes one face. Calculate A, the angle of incidence, B, the angle of minimum deviation. Solution. From the question, since it is an equilateral triangular prism, refractive angle is going to be 60 degrees. So from there, we can know the angle of refraction because A is equal to 2r. So making r the subject of the formula, r is going to be over 2, and that will give us 30 degrees. Then the refractive index is given as 1.5. So applying the formula, n is equal to sine over sine half. So 1.5 is equal to sine half over sine 30. So making high the subject of the formula, we have 48.6 degrees as our angle of incidence. B, we have to find the angle of minimum deviation, dm. So apply the formula, sine high is equal to sine half into a plus dm. So high is going to be half a plus dm. So which is going to be, when dm is made the subject of the formula, we are going to have 97.2 minus 60 to give us 37.2 degrees. So let us run over this again. So the refraction in triangular glass prism can be studied by using the following apparatus: a triangular glass prism, a meter rule, a ruler, a protractor, four optical pins, and drawing papers. So in the diagram shown, xy is the incident ray, yr is the refracted ray in the glass, yrs is the emergent ray. I is the angle of incidence, r is the angle of refraction, E is the emergent angle, where A, the capital letter A, is the refracting angle. So when the angle of incidence is varied, starting from 30 degree to 35, 40, 45, 50. And we plotted the various sign of angle of incidence to the sign of angle of refraction. We can verify Snell's law, which is going to give us a constant value, the slope of which will be approximately equal to 1.5, which is the refractive index of the glass. Also, if we continue varying the incidence angle, there will be a particular angle where we are going to get a minimum deviation through the prism. And at minimum deviation, the ray passes symmetrically through the triangular glass prism as shown. And when this is done, the refraction at the two surfaces will be the same. And this is equal to the sum of these two refractions. Angle of refraction will be equal to the refracting angle. And also, if we plot dm against height, there will be a particular angle of incidence when the deviation will be minimum. And that minimum deviation is known as angle of deviation, the angle of minimum deviation. So under this condition, A is equal to 2R and dm is equal to 2I minus A, where A is refracting angle, R is angle of refraction, and I is the angle of incidence. So the formula relating the refracting angle with the angle of minimum deviation is given, and refractive index is given by n is equal to sine half into bracket dm plus A over sine half A. That is, refractive index is the sine of the half of the angle obtained by adding angle of minimum deviation with the refracting angle divided by the sine of half of refracting angle. And the example 5 below shows how we can apply the formula. It is about an equilateral triangular prism of refractive index 1.5. So we have to calculate the angle of incidence and the angle of minimum deviation if the refractive index of that glass is 1.5. Being an equilateral triangular glass prism, the refracting angle is going to be 60 degrees. Then refractive index is given, so we have to find the angle of incidence from the fact that A is equal to 2R. So we can get the angle of refraction by dividing A by 2 to give us 30 degrees. So since we know the angle of refraction and the refractive index, so to get the angle of incidence, we just apply the formula that n is equal to sine r over sine r. And working through that, we are going to get 0.75 as our sine I. So making I the subject of the formula, that gives the arc sine of 0.75 to give us 48.6 degrees. Then to get the angle of minimum deviation, we applied the fact that sine I is equal to sine half into 8 plus dm. So I is equal to half into 8 plus dm. Substituting all the values we know and make dm the subject of the formula, we have dm to be 37.2 degrees. And this is the convenient point for us to put an end to the second period of week 7. Until next period, which is going to be the last for this week as per our e-learning class, I will advise you to go through all your notes, understand what we've done so far, so that you have a clear understanding of it. Until then, when I will come your way again, once again, my name is Oladimeji T.A., your physics teacher. Until next we meet, stay blessed and remain safe. Assalamu alaikum wa rahmatullahi wa barakatuh.